This question is about citric acid, a hydrated tricarboxylic acid. Its formula can be represented as H3Y.XH2O. A 1.5 gram sample contains 0.913 grams of oxygen by mass. The sample burns completely to form 1.89 grams of CO2, 0.643 grams of water. Show the empirical formula is C3H5O4. So to do an empirical formula, I like to do mass divided by AR, get moles, and do the simplest ratio. We know that the mass of the oxygen is 0.913. The mass of the carbon isn't the same as the mass of the carbon dioxide. 12 of every 44 grams, so carbon dioxide has an MR of 44 and carbon is 12. So 12 out of every 44 grams is carbon. If we work that through, we'll get 0.515. If we do a similar thing for the hydrogen, 2 out of every 18 of water is hydrogen. We get 0.0714. And then we divide those numbers by 12, 1 and 16. We'll see that we get 0.0429, 0.0714 and 0.05. Let me just check that one. 571. This is the smallest one, so this is going to be 1. If we divide 0.0714 by 0.0429, we get 1.67, 6667, so it's like 1 2/3. And if we divide this, we get 1.33, which is like 1 1/3. So if we multiply everything by 3 to get the simplest whole number ratio, we get 354. There's our C3H5O4. 3 gram sample of H3Y.XH2O is heated to constant mass to drive off the water. So to get to constant mass means all the water is driven off. We use 3.00 grams of this with an MR of 210. And we got 2.74 grams of H3Y, which if we subtract tells us we must have got 0.26. 3 take away 2.7 is 0.26 grams. We can work out how many moles this is. This is 0.014. And if we do the same over here, we get 0.014. So since these two moles are identical, 1 to 1, X must be a 1. Complete the IUPAC name for H3Y. So propane, so there's the 1, 2, 3 of propane, with the 3 tricarboxylic acids. And then we've got an alcohol group on number 2, but we're going to call that hydroxy because we can't put alcohol because we're calling it carboxylic acid. How many peaks would we expect in the carbon-13 NMR? Well, if we have a look, this carbon and this carbon are identical because it's symmetrical. This carbon is different because it's attached to the C with the OH. These two carbons are the same because it's symmetrical. And then the one in the middle is different again. And so in total we have got 4 different types of carbon in this molecule.